All right, so here's the syllabus. This syllabus is uploaded in Canvas, so you guys can access the syllabus in Canvas in several places. So the course is Comp 162. Here's me. Then the contact information is given here. So one thing important is the office hours given in here. So my office is in Solana 2178, but for current situation, I'm not there. So our meeting going to be online on Zoom. So at any time during this course, you feel that you need my help, please email me. We can set up a meeting during the office hours, or if you cannot make it, we can, come up with the time that works for both of us, and we can make it. All right, so this is the office hours. Now, regarding the class, so we have normally this course is a blend of lectures and labs, right? So for the lectures, it's going to be asynchronous. What this means is that the lectures are pre-recorded and they are available on the course Canvas page. You just click on them and then you can see the video of the lecture. So the reason that we make this one, you're going to make it more and more convenient for you, some of you that might be working during the day and do not have time to listen to lectures or to watch the lectures. So therefore, for the lecture on Tuesday, there are going to be no classes unless we set up a time, for example, to talk about the exam, for example, having a midterm review session or having a final review session. So I'll let you know in case we needed a Zoom meeting or Zoom lecture on Tuesday. But it is assumed that there's going to be no meeting on Zoom or in person during this time. But for labs on Friday, they're going to be synchronous. So you're going to be having a synchronous meeting, meaning that, so the lab is about like 3 hours, but our meeting during that lab is not going to take that long. We're going to be getting online. I'm going to go through the lab, explain the lab, the expectation of the lab, the procedure. So you guys going to be taking a look at that, see what the expectations are, so how you can do the lab. So provide you some hints, and then all we are after that 1 hour or half an hour, I don't know how long it's going to take, depending on the lab. If it needs more information, more background information, I'm going to stay longer. If no, it's going to be a bit shorter. So it's going to take something between like half an hour, maybe to 1 hour, occasionally maybe to 1.5 hours, it depends. But it's going to be short. So during the lab, so after we have the introduction to the lab and talking about the background information and the procedure, then you can turn off your device and start doing the labs for 2 or 3 hours if you are available during that time. If not, then you can come back to the lab, do it at your convenient time. You can do it at night. You can do it in the other in other days during the weekend. So that's up to you. But I recommend you to start completing the lab like as early as possible, because if you have any questions during the first few days, then you can have time to ask me, ask your friend in discussion board, find the answer, complete the lab, okay? So don't let that be accumulated to the last day of submission, which is Thursday. So all these submission dates are provided in the syllabus as I'm going to be showing at the end of this lecture. So required textbook. So we have one textbook that we mostly follow is this one. This one is a free textbook. It's online, available from this website. I recommend you guys to study this as we go through the course. We have supplementary textbook with the title Introduction to Operating System. So we are not going to deal with this book that much for the first lecture and for the last lecture. For first lecture, we can, since we are going to be talking a bit of the hardware that we are dealing with, some of the material taken from this book. And for last lecture in this course, which is an Introduction to Operating System, We tell you what the operating system is, how the system interacts with hardware, and how we can make it tiny operating system using assembly and C at the end. So we're going to be using that book a bit. But anyway, that book also is free. So you can go to this web page and access that text. There's another textbook in case you guys want to pursue a career in the area of assembly and hardware programming. You can take a look at this. It's very good book regarding the hardware interfacing. And lab references. Each lab has its own guide. So it's everything explained in there. If you need some materials, the link is provided. Everything is given there. But mostly we work with NASM as an assembly compiler. So this is a place to go if you need some information about the compiler. Tutorial Points is a good place to go for getting some information regarding the assembly language or C program. I guess you guys all know this one. Okay, tools and platform. So what are the tools and platform we need? So this course is different from high-level language courses like C, C++, Java, Python, and all of this. So those courses, those languages, they're high-level languages, and you don't need any information about the hardware mostly. So they're hardware agnostic. But for assembly, you need to know the operating system, and you need to know the hardware that you are running your program on. So if you write a program for x86 architecture CPUs, it will not run on ARM processor. Okay, so you want to interface some ARM processor, you need to know the hardware structure, the number of registers, the bus system, the ALU, the bus interface. So you need to have some information about that. And once you get those information, you also need to know the names, how the manufacturer names all these registers in their system. So that when you are writing your code, you address some register, you need to know the name of that register in order to put some information in it, take some information from it. You need to know the name. So the hardware that you're going to be working on is x86 architecture. Some of you may know this CPU. This is a CPU that's used in most desktop and laptop devices. And we can say probably more than 80% of the devices, laptop and desktop, are using this processor. The reason that they chosen this one is because it's widely used. And if you're going to go to industry and do some work, this is very, very related. Operating system is Linux. So if you are familiar with Linux, that's perfect. If not, this is a good point to start, okay? So in lab 1, I included a Linux tutorial in lab 1, so you can go through that and do the syntaxes one by one, see the results, and play with it to get to know the Linux. The learning curve for Linux is a bit longer than Windows operating system that everybody, regular person, can use. Linux is a bit more professional, especially for your computer science guys and IT guys and even the mechatronic students. So as a person that working specifically in this area, you need to know how to work with Linux. So I recommend you to learn it. It was easier for me to just go to Windows and teach you assembly in Windows, but assembly and C used to learn, to write operating system, and this happened normally in the Linux environment. So you need to somehow at some point in time in your study to get exposed in this environment, and this is a good place to start. So the assembler that's going to be compiling your assembly code is NASM. Compiler for your C going to be GCC. Again, it's going to happen in Linux. And linker is LD. If you are not familiar with any of these terms, don't worry, you're going to be learning about this a lot during this course. All right. next, the course description. This is an introductory course to computer architecture and assembly programming. Okay, so we are going to learn about computer architecture and basic assembly language and system software and computer application. So this is a course, and these are the requirements, official requirement for the course.
I'm so sorry, I hate to interrupt. I have a small monitor. Can you zoom in a little bit?
Okay, sure. So let me, yeah. I don't know if this is
so much better. Thank you so much.
No problem. By the way, the course syllabus is available on course Canvas page. You can download it and take a look at your time as well. Okay, so these are the prerequisites, the official prerequisites for the course. And so as you can see here, so you are expected to know logical and bitwise operation like AND or XNOR and NOT and so on. So how to do 1-bit operation using this logical operation, how you do multiple bits of them. So it's called like bitwise operation. So you have, for example, 111, you wanna AND it with 1010, right? So how do you do that? And then we are gonna needing to know number representation, how hex can be converted to binary, how binary can be converted to hex and decimal and so on. So we are expected that you guys know how to do the addition and subtraction in binary format or hex format, right? So, and what is the difference between signed and unsigned binary addition? So the notion of one's complement, two's complement, are kind of included in this topic. So most probably in your introductory course in any of these, you have exposed to writing the pseudocode and drawing algorithm flowchart. So once you want to do programming, so one of the first steps, so the client comes to you, say that I want to do this, I need the software to do that. The first thing you do, you draw a flowchart of your system or write the pseudocode of that, right? So for any programming languages, no matter what the syntaxes are, you need to know how to draw a flowchart and write in pseudocode, plan your code, and so on. One other requirement, basic in C programming. So you need to know the basic in C programming. You are not required to know, for example, the structure or polymorphism or some of those terms. So you need to know the basic in C, okay? How you can write a program that can read some numbers from the keyboard and add them to some basic processing and print the result back into the screen, right? How to print a string on the screen, and such basic functionality. So you do not need to be very proficient in C. If you are familiar with any high-level languages like Java and Python, it is going to be taking like about 2 days to get the basic in C program. It's not difficult. But please go, if you have passed the course in this area, that's perfect. Do a bit of review. You don't just go to the tutorial points and in the C section, in the C programming languages. It's a nice tutorial. It's going to take you 2 days to complete that. So go through that and complete that. The first assignment is about, by the way, about C programming. There are going to be multiple choice questions in that assignment. So in there, you can try what the level of your proficiency is in C. Just try it. I let you guys to have multiple attempts for that assignment. So in case you don't get it the first time right, then you can try it for the second time. And also you guys can run this program and see the output. Okay, so this is a program. Let me first think how the output is going to look like on the paper. So how the algorithm work, how the while loop work, how the for loop works, how the prints work. And then, so what are the expectation of the output? Okay, I see that, okay, my analysis shows that the output of the program is going to be this. So you choose that response and, and you submit it. Then it says that, okay, that response is wrong. Then you try the second time, try to go to the program second time and see what the issue is. But if after the for multiple times attempt you didn't get that right, then you can run the program. Take that basic code and put it in some environment and run it and see what the outputs are. And from there, probably you can realize where the mistakes are. But this is multiple choice. If you do a bit of a C study and C review, you're gonna get that right. One thing that I want to mention is that I would love to go through all this material. All this material, the prerequisite material, are interesting, okay? And I would like to go through them in the class, but since we have tons of material in assembly and computer architecture to cover, because the topic is hardware and software, there are tons of things. If you go to lecture one, you're gonna see what I'm talking about. So we don't have time to go through this, okay? So these are something that we can't, because these are the prereq, right? So you're expected to know, and we don't have time to go through this in depth. So it's gonna take like a month or so to cover all this in the class. So we do not have enough time to do that. Please cover this if you want to have a smooth and pleasant learning experience in this course. As you will see, assembly is not that difficult if you know the fundamental and concepts and the basics in programming. It's not going to be difficult. But if you don't know any of this and don't know how to convert binary to hex to binary, and then you don't know how the bitwise operation works, then it's going to be a bit challenging, because we work with bits and bytes in like data manipulation, right? We do a lot of data manipulation. We do a lot of data transfer. We need to know the bits, each bit on those data, how they are transferring in the hardware, and how all these functions happening there. So you need to know the data type and the data representation in order to track all those changes and data manipulation. All right, let me go. Okay, this part. Grade distribution. Practice and participation include Zoom meetings, surveys, and quizzes is 10%, assignment 10%, discussion 10%, and labs 20%. Midterm 15 and final is 35%. So if you want to succeed in this course, please do the homework, okay? So try to attend the Zoom meeting, try to do the survey. We have one learner survey at the beginning of this course. Please go and do that. And do the quizzes, and I'm going to let you to have like multiple attempts in case you don't get it right in the first time, then you can get it right in the following attempts. So my recommendation is, if you want to succeed in this course, please do the homework and be on time. If you lose one topic this week, it is going to be very difficult to catch up next week. Okay, so as we go on, try to do, the assignment on time, so that you can, because the consecutive topics that comes, it depends on the topic before. If you don't learn that topic, it's going to be very difficult for you to catch up. But if you do well in your homework, then you're going to do well in your midterm and final exam. I'm going to get a very good grade in this course, that I promise you. I also have uploaded some students' advice from the previous students in the course Canvas page. You guys can take a look at that and see what their recommendations are and how their experience was in taking this course with me. Okay, so this is a tentative lecture schedule for the course. We have 14 modules for this course, okay? We have 16 weeks, but we have 14 modules, designed for this course. 2 weeks is 1 week is for midterm and 1 week is for final. So they have this 14 module, and we try to stay with this schedule, so you know everything in advance, what's going to happen to week 1, week 2, and so on. So for module 1, you guys gonna have like lecture video 1 and lecture video 2. So please go through this lecture. From the slide, I posted a slide just for your information. The lecture slide is not the source of learning, okay? So in order to understand the lecture slide, you need to listen to lecture video. Lecture slides are there just for you to refresh your memory if you forgot something when you advance through the course. You come back, you take a look at the lecture slide. Oh, I know this one because I listened to lecture video and this is referred to that topic. It is not only the source for learning. Listen to the video tutorial if you want to understand the topic of that module. So it is very necessary. Lecture slide is just to track the information back to the video, okay? And some of the module I provided, programs. So every lecture, not every, so most of them, we are working with some programs, right? So this program made available to you. Please download those programs and put it in your Linux environment, then run them, and then go change something, see the impact. So they're going to be very useful. So I'm uploading all these in Canvas so you guys can access for your experimentation. It's going to be very, very useful in your learning. So make sure to use these resources. They're very useful. Okay. We have about 12 assignments, 12 labs, and 12 discussion activities. And so the deadlines for all these activities are listed in this table, okay? So you know that module 1, assignment 1 is due at September 1, okay? So you're gonna be working with your teammates and on this assignment, and then each of you individually gonna be submitting your own work. So if your work, lab work or homework is similar to your teammate, that's fine. That's not considered as cheating or plagiarism. So, but there is a cover page for each assignment and lab that you include. So I know the name of your teammate, so I don't see that as plagiarism. So your work can be the same, but everybody is responsible for its own submission, okay? So don't rely on your friend's submission because that's not counted toward your work. Your work is your own submission. Just you know this because in previous semester, sometimes some student forgot to learn, submit the work, and then the other student get punished because of that. And we do not want this happen this semester. And we want this group work, this team work to help you to, to have a better learning experience. If at some point you see that the teamwork is creating a lot of hassle and overhead work for you, just send me an email saying that, okay, my partner is not collaborating, is not cooperating, is responding late, is not, working the way that I expect, and I want to work alone. And I have absolutely no problem with that. So just I create these teams to help you to have a better learning experience, exchange idea with each other, probably help each other in some parts, divide the workload, and then explain more interaction. So that's the point of this team. If that's gonna create problem for you, just send me an email, say that, okay, I prefer to work at this point individually because my teammate is not collaborating the way that I expect. And I'm perfectly fine with that. So for your deadline, just please refer to this table. Please make it, please try to not to miss a deadline, because as you can see, for every week you have some submission to do, right? If you just delay that, your work gonna be accumulated and then you're gonna be stressed out. So try to do each homework at the week that you are in, so not to delay that. It's gonna be very helpful if you do that. Learning environment, okay, discussion board guideline. One important point is that to get the full credit for your discussion, you need to have one post at least in the discussion, and you need to at least respond to one of the other posts. So your post can be about an interesting topic that you learned from the video lecture. You're gonna say, okay, in this video lecture, I learned like topic A, we do this using that, and it's interesting. And that's the reason you are discussing that with your friend and express your takeaway from that topic. So that could be one way to post something. The other way is if you have questions regarding a lab or assignment, you can post it in the discussion board saying that, okay, I did this, I did that, but I do not get the proper answer in that. So I'm wondering which area should I take a look at more, or what I'm missing in this, for example, in this part of the code. So you can discuss that. For posting question, even you get credits. And so once someone posts something, try to read those posting and then provide an answer to one of those posts to get the full credit. So to get the full credit, you're required to do one post, and you required to respond to one of the posts. It's very easy. Just discussion board is not, it is designed to help you to do your homework and your labs in a better way. So if we are kind of creating the physical class environment in an online setting. So that's the point. So we want to create such an interaction in online setting. So that's the reason you're gonna be having this discussion board. Last semester, I had this discussion board and a student used it a lot and they really loved it. So you get credit for asking questions, then you get credit for posting a question. And you're gonna be seeing that. It's kind of simulating the class environment. You're gonna be enjoying that a lot. All right, communication policy is something that I forgot to tell you. If you send me an email or you have some question, I try my best to answer your question within 24 hours, okay? So Monday to Friday, but during the weekend, if you send me a question or an email, you get answered probably on Monday. Okay, so this is pretty much about the syllabus. If you guys have any question about the syllabus, please feel free to speak out or you post it in the chat room. Okay. Now we're gonna go, so let's see the time, 10:54. We're gonna go to the course Canvas page. So we have one chat, see what it is. Okay. Okay, everybody sees this this page, the course Canvas page? All right. Perfect. So if you're familiar with Canvas, that's perfect. If not, you're gonna be learning that in this course. You're gonna be using Canvas as a platform for our course. So anytime that you have a question, probably the answer can be found in the course Canvas page. So here is the start here. You click on this, you go to where you need to start. The course module are in here, and student support, you can click on here, and for virtual lab, you click in here. So that's one way to navigate through the course. The other way that you can navigate through the course is using these menus on the left of the screen. Okay, so you can, for example, go to the announcement to see the previous announcement in here. And you can go to syllabus. It tells you what the syllabus are, so you can download the syllabus from here. Some of the information regarding course schedule and grading assignment are given in here. You can access those directly. Student support are provided in here. And then we organize the modules over here. Okay, so the first we talked about, in case you have a question, it's going to direct you to the discussion board. So this is the introductory modules. It tells you how the Canvas works. how you can meet your instructor, what is the community ground rules for using this platform, how is the course structure, how you can contact me, and how you can access Zoom. Once you complete this course, there are like learner information survey. It's some basic information about you, about your major, about your background. Yeah, there is no right or wrong answer. There's gonna be, I guess, 8 questions in there. It's gonna take about probably 10 minutes to complete that. Just please go there and complete it. And then your badge, 101 badge, also take about 1 to 2 hours to complete. Do this and submit it. This is gonna be as part of your practice and class participation, okay? So don't miss that. Then we start module 1 in here. So we have module overview, video 1 and video 2. I also posted the slide, but don't rely on the slide alone. It's not enough to, tells you all the information. The information are given in the video, okay? The slides are only used to review those information presented in the video. Then you have your assignment 1 here, lab 1 here, and your discussion here, and it's gonna be end of your module. So once you do that, these are the duty that you need to fulfill for this module 1. And here is the module 2 module overview. Okay, advice from past students are uploaded in here. Probably you guys don't have access to module 2 yet. I'm going to be providing access soon. So you can click on this and see what the past student telling about this course. One thing I would like to tell you is that many of you may have heard that this course is difficult, right? So I'm gonna say, yes, the course is difficult. The reason is that it is different from the high-level language courses like, C++, Python, and Java. So for those courses, you don't need to have an understanding of the hardware platform. And for this course, you need that. When you deal with the computer system, hardware is a complex system. A lot of different registers in the system, the bus interface, the acronym, the names, all those hardware names and acronym are gonna be used in your program. This is a time-consuming process. So in Python, you don't need to do that. You're agnostic to the hardware platform, right? So you don't need those information. That isn't the learn curve for those high-level languages is much quicker than this one. This course requires time and patience, okay? So if you spend time, if you go through the materials, you run the program, if you pay attention to detail, it's gonna be very pleasant course. It's gonna be very sweet. But if you allocate the same time as like introduction to programming for this course, this may not work. It's going to be very challenging. So my recommendation is for you to at least spend 20 hours, allocate 20 hours per week for this course if you want to succeed in it. Maybe for other courses, 5 hours per week is enough, 5 hours or maybe 7 hours. But this course requires at much 3 times higher. If you are very unfamiliar with those topics, the requirement topic, the prerequisite topic that they presented in the syllabus, then you need more than that. So if you haven't exposed to any, for example, logical or bitwise operation, right, and you don't know what the truth table is, what AND is, what XOR is, then you need to study those, right, those material. Then you need to add that time to these 20 hours. If you don't know about the number representation, how to convert hex to binary, binary to hex, how to add these two, how to add hex numbers to each other or binary number to each other, or what the sign and unsigned operation is. And if you never heard about 1's complement, 2 complement, right, then you need to spend more time. So I promise to you that everyone spend enough time in this course gonna be passing the course. I can promise every one of you that you are all able to pass this course as long as you do the homework and spend the time required to learn the basics. I hope this answers your question. You can also take a look at the advice from past students to get more idea about this course and the material and the way that you should plan for it, okay? So at the beginning of the semester, I'm saying that, okay, this is the way to go so that you know, because you cannot compare this course with many, many other courses in computer science, IT, or mechatronics. I'm telling you that. So this course requires more time. Please allocate the time accordingly to have a pleasant learning experience in this course. Okay, so this is it that I want to mention. So you can access the discussion board from here. You come here, for example, the module 1 discussion right now is posted, right? You can click on it, and to post, you can just reply to this and discuss the interesting topic that you had during the lecture 1. Or if you have any question regarding lab 1 or assignment 1, you can post it in here. So the due date for completing this discussion is Thursday next week. So you have time to do that. And so once the due date passed, the system is going to automatically be locked. So you can't submit any discussion, because after that, it does not make much sense to post anything, because the students are moving to the next discussion board, right? And the assignment and lab are kind of closed. And if you ask question in this discussion board in that time, then the other student can't, they do not have access to the discussion board to answer your question. So start your assignment and lab early so that you can get help from your fellow classmates. Assignment that can be found in here, the way that each assignment contribute to the final grade are given in here at the right corner of each assignment group, so that you can take a look at that, and you can take a look what is due from here as well. Then we have quizzes, we have grades, and we have Zoom, okay? If you want to join a Zoom meeting, I guess all of you know at this point because you have joined the Zoom. So you're gonna be, okay, so this is where that I scheduled the Zoom meeting. I guess you guys can also set up a Zoom meeting with your friend in this board. I'm not 100% sure, but maybe you can. So the other thing is the calendar for the course. So you can click on here, and as you may see in here, for our Friday lab, which is going to happen at 9 a.m. So the link given in here. So once you click on this, here is the link, and then you click on the link, and then you join the meeting. So the lab going to happen at 9 a.m. on Friday. As I said, the lab may take about half an hour or 1 hour, depending on the lab, but it's going to be very useful for you to be in this lab. To this lab session, it's going to get a lot of information in there. In case you are a full-time worker and you can't make it to lab, send me an email. Then we come up with a plan for you what to do, okay? That's pretty much it. Okay, one thing else that I would like to mention in here is about that the environment that we are programming is Linux, right? So how you can do the programming in Linux? So there are two ways that you guys can do this, okay? One way is your own personal computer. You install Ubuntu 18.04. This version is given in your lab number 1, so don't worry about this detail for now. So all this information given in there. So you have two options. One is to install Linux on your system. You can make it dual boot, or you can use like VirtualBox to do that. If you are not want to make it like actually make it. If you do not want to make your system dual boot, or you are not that experience in that area, you can easily install VirtualBox on your system if you have Mac or Windows, and then you can install your Linux on the VirtualBox. Basically, VirtualBox is creating a platform for you to install multiple operating systems in your system. Your system can be Windows, but VirtualBox lets you to install different Linux distribution on your system. You can have Ubuntu, you can have Kali Linux or other version of the Linux in your system without, reformatting your hardware or making your system dual boots or triple boots. So that's very convenient. So in case you're liking to do that, installing VirtualBox, then you can install like Ubuntu. All these instructions are given in the lab. So you can go ahead and do that. But in case, say, okay, I don't have time, I don't want to go through that process, I don't, my computer is not high speed and it's a bit slow, I can't do that. So in that case, you come here and you go to Virtual Lab. In Virtual Lab, so I set this up. This Virtual Lab uses the Microsoft Azure cloud. So you can have access to the virtual machine in here. For this virtual machine, in here, I actually created the machine for each of you. So once you click in here, that's the instruction. So once you click in here, you can access the lab. But in order to access this lab, you need to go and do a bit of setup. So I registered your name in the system. Go to this instruction to activate your account in there. So once you activate your account in there, if you click on this, then you can access your Microsoft Azure environment. It's going to be prompting you to your CSUCI account, and then you verify that, and then you can access the lab. And so once you are there, your virtual machine going to be in there. So you just click on your virtual machine and you get to your system. So I have in my lab 2 different classes. One is computer architecture and assembly language. The other one is artificial intelligence. That's the course that I'm teaching at graduate level. And here is your course. So you just have that one. And then for you only have one of these menus that tells you, okay, connect to your machine. And then we click that, USSH, and you go to your command line, then you in Windows or in your command line interface in Mac, and then you type that SSH, you get into the machine, into the cloud, and everything in the cloud is set up for you. So in there you have Ubuntu version 18.04, and you have the assembly library set up and ready for go. So the only thing that you need to do is that to copy your files from your host machine to that remote machine. So the instruction for to do that also can be found in Canvas in where that I just show. Let me go back to that again. So in case you are not familiar with with SSH command, you haven't done anything on Linux, those information also has been given in there, so you guys can access. Okay. Okay, virtual lab. So whenever you want to access, just come here and click on virtual lab. The information to access that is given in here. So once you download this, it tells you how to set it up and tells you the command line to copy your files from your host machine to the remote machine, and from the remote machine to your host machine. If you have like one file or multiple files, all of them are given. So these are the instructions to set up your lab, and these are the instructions how to copy files between the remote machine and the host machine. You can go through that and see. see which way you are more comfortable. Are you comfortable to set up all these things in your computer, or you are more comfortable working with the virtual machine in the cloud? That's gonna be your decision, and see what your preferences are. Okay. I guess we are at the end of this introductory session. I mostly cover what's needed at this point. In case you guys have any question, please go ahead and ask me.